Very good afternoon, dear students. Today we are going to discuss another important topics of microbes and environment, drinking water purification methods. As far as environmental microbiology and microbes and environment paper is concerned, this is one of the most important topics of human requirement, and this topic is another important aspects of this particular unit. In fact, we have discussed the important aspects of aquatic microbiology and water microbiology in this unit. So now, based on the importance, we are going to see how this waste drinking water are purified, and what is the necessity of drinking water purification, and what are the steps that is required for the purification of drinking water. And before we are going to discuss the detailed step, we, as an introduction, we should know that what are the basic necessity and need for water purification. As you all know, water is the one of the most important commodities. As you know, without water we cannot even survive at least for 2 days. But without food we can survive many days. But without water we cannot survive in this in the ecosystem. Not only human, all the organisms are like that. According to the World Health Organization, as per the report based on 2007, little bit old, approximately 1.1 billion people lack adequate water facilities, especially for the drinking water for their survival. And 88 percentage of 4 billion annual cases of one of the main waterborne disease called diarrheal disease are mainly due to the unsafe water, inadequate sanitation and hygiene. Okay, so the unsafe water consumption and inadequate sanitation and hygienic facilities are the main reason for the several diarrheal diseases in this world. And 1.8 million people die from diarrheal diseases in every year. Okay, and and although all those problems are there, 94% of the cases can be solved by using the adequate water facility and the modification of the environment to access the safe water. And there are methods such as some simple techniques such as chlorination. You know that the chlorine water, okay, chlorination, we will discuss that. Filtration and solar disinfections, and for storing in safe container could save a huge number of death in every lives and save a lot of people. Okay, so this is another important aspect. So we have already discussed the waterborne disorders in the previous class, and all these waterborne diseases can be prevented in the public health biology, which is one of the most important goal of water purification. And if you want to purify water, if you simply look the water, we will not understand whether the water is contaminated or not, because water can have so many particulate material that is not able to see directly, and so many other microorganisms also pollute the water. We have already discussed the fecal pollution, and the visual inspection cannot determine the quality of water. Okay, and there are procedure. Even if you boil the water, the microorganism can be killed, but the suspended material cannot be completely removed. Okay, or the use of household activated carbon filter. There are filters. Okay, even if you use household activated carbon filters, we cannot properly treat the contaminated water, and these techniques are not sufficient for treating the contaminants in the water. And even natural sources like the spring wells, okay, all the sources, the water need to be tested before determining the quality aspects of the water. Thus, a chemical and microbiological approaches are required to treat the and purify the water that helps to obtain the information necessary for deciding the quality of the water that is suitable or not, okay, and whether we have to use the water for purification or not. So due to all these aspects, the water need to be or must be purified before the utilization, okay. And as you can see in the picture, there are the water bodies, okay. There are so much contaminated, and these water bodies are contaminated due to the waste that is obtained from the agricultural, from domestic waste and industrial pharmaceutical wastes are completely dumped. And all this picture you can see that the water is very much essential, and these kids are mainly, they are carrying from the developing countries, they are carrying the contaminated water for human consumption. Here you can see how, what a very pathetic condition here. The animals are here, all the farm outlets, and as well as all those kind of waste materials are completely obtained here. Here you can see there are people uses all this waste. People uses the water that is completely contaminated with this particular waste material, okay. So here you can see, so this clearly shows that why the water need to be purified. That is what I told in the previous slide. There are a huge number of people, they don't have an adequate facility, they are only using the contaminated water for their daily survival, okay. So water purification is very, very important task. And water purification, it is a process of removing undesirable chemicals, biological contaminants such as bacteria, viruses, then in fact protozoa, algae, then fungi, etc., and the suspended solids and gas from the water. And this process of removing all the contaminants from the water is known as water purification. So the main goal is to provide or produce the water that is fit for specific human purpose. The specific human purpose, the main important purpose, water is purified and disinfected for human consumptions, for drinking. The major condition here you can see, people are compelled to drink contaminated water in the absence of the purification, okay. And other thing, not only the human consumption, but the water purification may also carried for the variety of other purpose, including the medical, pharmacological, chemical and industrial purpose, okay. The medical, pharmacological, chemical and industrial purpose, okay. So the methods, there are so many methods can be used to purify this particular water, such as filtration, sedimentation, distillation and biological processes such as slow sand filters or biologically active carbon filters. The chemical process such as the flocculation and chlorination also can be used. And the use of electromagnetic radiation such as ultraviolet rays also can be used for the purification, okay. And the water purification mainly done for the two important goals. One is to reduce the concentration of the particulate matter, including the suspended particles, parasites, bacteria, algae, viruses and fungi, okay. Then in addition to that, which reduce the concentration of the dissolved and particulate matter that is present in the water bodies, okay. So these are the main objectives. And you have already studied what are the major source of water, okay. So you know that the major source of water is the surface water and groundwater, okay. The groundwater, that is spring wells, bore wells, okay. All those things you can see. And there are lakes and reservoirs are also there, okay, and the surface water. And the rivers, canals and lowland reservoirs are also present. Then atmospheric water is very, very important. Then another important, the harvested water during the rain time. Okay, so whatever the rainwater harvesting approach, we have collected lot of water, that is also another source. Or fog collection, if you collect the fog and the fog can convert into water. Okay, then desalination of the seawater, desalination, removal of the salinity from the seawater, and that is salinity means salt concentration. You need to remove the salt concentration from the seawater, that also another important source. Then the various other surface waters also can be used as the sources of water. And these are the overview of water purification. The main important goal or objective for the water purification approaches are to remove the unwanted constituents or components in terms of the particulate matter and microorganism in the water, and to make the water safe to drink or fit for a specific purposes in the industry or medical application. I have told not only the drinking, but there are so many other purposes like medical, pharmaceutical, chemical and industrial purposes. So this is the main important aspects of the water purification. And this is the overview of water purification. The water need to be pumped from the source, and the large particulative and big waste material need to be screened by a process called screening. Then after that, the screened water need to be pre-chlorinated. Okay, then after that the pre-chlorinated water need to be checked for the hydrogen ion concentration or pH. That pH need to be adjusted, because pH is the having a direct connotation between the contamination. Then it will transfer to the flocculation. Okay, there will be a process. Then the flocculated water need to be sedimented. There is a process called sedimentation. Finally, the sedimented water need to be filtered, that is known as filtration. Finally, the water need to be disinfected, that is known as a disinfection by certain chemical agents such as chlorine or bromine or halogens. Okay, so these are the main important main steps. That is, in one way we can say these are the major approaches for the water purification methods. Now we are going to discuss the important step. The first step is the pre-treatment. There, the pumping and containment. As I told, the first step is the pre-treatment. Majority of the water must be pumped from certain canal or a river or a pond from its original source and directly directed into pipes or holding tanks. Okay, the water from various sources will be collected and transferred or passed to the pipes or holding tanks. Okay, then the next is the screening. Okay, the screening will remove the larger debris. Okay, whatever the larger debris such as can, bottles, okay, plastics, sticks, leaves, okay, rubbish and other larger particles which may be interfere the subsequent purification. So large components need to be, which are the things physically we can see, the big materials, okay, papers, okay, boxes, all those cans, tins, all those things can be removed, or cloth materials, all those things can be removed. That is known as screening. So the groundwater, only this is required for the surface water. Groundwater doesn't require any such kind of screening before purification steps. So once screening is done, the water need to be stored for a very long time. Okay, so water from rivers may be also stored in the bank side reservoir. Okay, there will be a lot of bank side reservoirs are there, or tanks will be there, or big water house will be there. For there we can store the water for between a few days, and it will take several months to allow the natural biological purification to take place. So when you are treating that particular, when you are storing that particular water for a very long time in a big tank, okay, so then the biological natural purification process will take place. So that will be purifying the water. This is one of the most important steps. Okay, this is important if the treatment is very treatment by sand filters or slow filters are required. Okay, and the storage reservoirs provide a buffer against the short period which allow the water to be purified very fast, and the transitory pollutant incident of the source of a river. So it will be decreases the pollution from the original source. Okay. After that, the pre-chlorination. This is another important steps. Okay. So here now we are here the pre-chlorination steps. Okay. So the in many plants the incoming water was chlorinated to minimize the growth of fouling microorganism on the pipework and tanks. Okay, so the water from the original tanks, original source consists of a huge amount of fecal coliform, probably because the water is reached from the domestic and pharmaceutical or agricultural form. Okay, as household waste material, it has got a lot of fecal coliform. Those fecal coliforms can be reduced by adding chlorine, because chlorine is toxic for the bacteria and the bacteria will be killed. Okay, so that is known as pre-chlorination. So once the pre-chlorination is done, the next important thing, the water need to be pumped into a big tank and the pH need to be set actually. Okay, so the pH adjustment. Okay, why this pH is important? Okay, so the pure water that has the pH is neutral, that is close to 7, which are either alkaline or acidic. Okay, so acidic pH means the pH below 7 is known as acidic, or alkaline pH or basic pH is the pH above 7. So 7 is neutral. The pure water doesn't have a pH variation. So, but in the case of seawater, it has lot of salt content. Thus, the pH will be increased. That is slightly, not slightly. That is highly alkaline. Okay, or moderately alkaline. But in the case of fresh water, that is undergoing wide range of pH value. So if the water is getting the waste material from the factories, mainly from the acids, okay, then the pH will be decreases. So if the water is acidic, that is the pH lower than 7, you need to add a sodium hydroxide, which is a chemical, okay, or lime or soda ash. Okay, that's known as lime or soda ash, that can be added to increase the pH during the water purification process. Okay, so when the pH is increases, the making the water alkaline, which helps the coagulation and flocculation process. These are the two important processes in the water purification that can be done very, very effectively. So the water is acidic, then the pH can be adjusted by adding alkali. Then if the water is too alkaline, okay, if the water is too alkaline, then the acid, okay, then we need to add acid such as weak acid such as carbonic acid, or some strong acid hydrochloric acid, or some strong acid sulfuric acid can be added and can be balanced to reduce the pH, but it need not be reduced to too acidic. Okay, actually an alkaline pH is appreciated. So this is the pH adjustment. So the next one is the flocculation. Okay, so here the coagulation and flocculation is another important method. So this is one of the first step in the actual water purification step. Okay, so the addition of chemical to assist in the removal of a particulate suspended material. Now what you have done, we have removed large particles, but there are microorganisms can be reduced by chlorination, but there are a lot of suspended materials, okay, that can be removed from the water. And the main contaminants, the clay and the silt, okay, the clay and silt and microorganisms such as bacteria, viruses, protozoa and natural organic matter, okay, such as fecal matter. Okay, so then the addition of organic coagulants, what you need to do is, first we are going to perform coagulation. Okay, so coagulation, when you need to add inorganic coagulants such as alum. What is alum? It is aluminium sulfate. Or you need to add iron salt such as iron chloride. Okay, iron chloride or aluminium sulfate you can add. So what will happen? So it has a lot of negatively charged. The negative charge on the particles are neutralized by the inorganic coagulant. Okay, the negative charge on the waste material, suspended particle, which are charged particle, that can be neutralized by the inorganic coagulant. Okay, and finally what will happen? Metal hydroxide will be produced, and this metal hydroxide is known as flux. Okay, once you once you add a coagulant, flux will be produced. What is this flux? These are metal hydroxide which will be precipitates. Okay, and this precipitates combines with the large particles under natural process such as Brownian movement or Brownian motion. Physics students, you know that what is Brownian movement. Okay, one type of specific type of motion. Okay, and which mixes and forms the flux. Okay, so this precipitates combines with a large particulate material and forms what? Flux. Okay, and this process is known as flocculation. So this is another important aspects of water purification. And this amorphous small metal hydroxide interacted with a large particle, then it forms an amorphous metal hydroxide, that is known as flux. Okay, during this particular flocculation, flux will be produced. So first coagulation followed by flocculation. So this amorphous aluminum and iron hydroxide that absorbs and removes the particle by subsequent process of sedimentation and filtration. The next one is sedimentation and filtration. This aluminum and iron hydroxide will absorb whatever the impurities are present in the water, they will remove that is from the water. Okay, so that is the next important steps. Then next is the sedimentation process. So sedimentation is nothing but there are so many particles are there. After coagulation and flocculation also they will be remains. Okay, so that particle also need to be segregated or separated. So that is known as sedimentation. Sedimentation means settle at the bottom. Okay, when you are undergoing the sediment certain forces, okay, this particular waste material will be settled at the bottom. Okay, so then what will happen? The water coming from the flocculation tank will enter into the sedimentation basin or a tank or that is known as clarifier or settling basin. Okay, so that is settling tank. Okay, all the impurities will be settled at the bottom. It's a large tank with a low water velocities. There will be water velocities. Due to that water velocities which allow the flux to settle at the bottom. Due to the water velocities, the flux will be settled at the bottom. Okay, so the sedimentation basin is located very much close to the flocculation tank, so that the transit between these two processes doesn't permit a settlement or flux to break up. Okay, the flux, if it is break, then again it will be spread a very minute particle to the water. So the flocculation, immediately after the flocculation, the water will be pumped into the sedimentation basin. There will be apply of low water velocities, so it will be settled at the bottom. Okay, so the sedimentation basin is generally rectangular, where the water flows from end to end, or circular, where flow is from the center outwards. There will be flow and there will be circulations. Okay, due to that particular thing, there will be forces that acting on, and the flux will be settled at the bottom. Okay, then so once the flux are settled at the bottom, that is full of impurities. So the bottom part, the flux, that is known as sludge or waste, need to be removed. That is known as sludge storage and removal. Okay, so once the particles settle to the bottom of a sedimentation tank, a layer of sludge is formed. Okay, so deposit, the mud, okay, or the sludge or waste is formed on the floor of the tank, which must be removed and treated. Okay, once the sedimentation basin is when the water is once the particle is settled on the bottom from the sedimentation tank, a large layers of sludge is formed that will be settled at the bottom. So this sedimentation basin may be equipped with a mechanical cleaning device. Okay, automatically at the bottom there will be mechanical cleaning device that continuously clean the bottom. Okay, that is the way how sludge is removed once it is settled at the bottom. Then the water will be passed through the next tank. Okay, Then the flock blanket clarifiers are also present. The flocks, the removal of particulate material by entrapment in a layer of suspended flocks as the water forced upward. Okay, so there will be a flock blanket clarifier. So when the water is forced upward, the flocks will be removed by flocks blanket clarifiers. Then there are another method called DA of dissolved air flotation. So when the particles to be removed do not settle out of the solution easily. So if the particles are not settling at the settle out, then we can use a dissolved air flocculation. I am not going to discuss about this. So this is another important method. So this is the way how once the sedimentation tank, that is when the water is passed through the sedimentation tank, the water will be moved to the next tank, but the bottom there will be the sludge that is flocculated and that will be removed. Okay, the sludge storage and removal, flock blanket clarifier and dissolved air flotation can be done. So that is known as sedimentation methods. Then the next one is filtration. Okay, so the filtration, after separating most flocks will be removed, the water is filtered as the final step to remove the remaining suspended particle or unsettled flocks. Okay, the previous method, if there are any impurities are not possible to remove, then that will be removed during the filtration. Okay, so this is almost the final step. So there are three important filters. One is rapid sand filters, next one is slow slant filters, next one is membrane filters. Okay, so we have already discussed membrane filtration, water quality analysis in the previous class. Okay, so what do you mean by rapid sand filter? This is the most common type of filters. The water moves, in this method the water moves vertically through the sand which has a layer of activated carbon or a anthracite coal above the sand. Okay, there is a sand bed, water need to be poured to that particular sand bed. That sand bed above that there is an activated carbon. When the water will be pouring to that activated carbon, the water impurities will be absorbed by this activated carbon or anthracite coal. Okay, then the filters out much smaller particle than the paper and the sand filters can. Okay, so this is one of the advantage. Okay, this sand filter can filter much smaller particle also can be filtered, and in fact other filters cannot be done. Okay, next one is slow sand filters. This is a rapid sand filter, very fastly the process will happen, but the next step is very slow. Slow sand filter may be used where there is sufficient land, there are a lot of acres of land and lot of waters need to be purified and space as the water flows very slowly through the filter. Okay, there are filters, lot of big acres of or hectares of land. The water will be pumped and this water will be having the sand and that will be filters, and the filters are dependent on biological treatment process for their action rather than the physical filtration. There are biological processes, there are microbial activity also, there are a lot of microorganisms that can remove this particular waste material. Then membrane filters we have already discussed. The membrane filters are widely used for filtering the drinking water and the sewage, where we are going to pass the water through a membrane. Okay, we have already discussed the membrane is having the lot of tiny spores. Only water, all the bacteria and all those things will be trapped over the membrane. Only water will be passed through the membrane. So that water is the next water. Then the last step, once that particular water is purified, all the small particulative microscopic particles are removed. Now the water is again need to be purified by disinfection. Okay, now there are a lot of viruses and bacteria, they have already passed through all the process, so that need to be killed once again. Okay, so the disinfection is accomplished by both filtration and disinfection. So where the harmful microorganism and by adding disinfectant chemicals can be used, and harmful microorganism and by adding disinfectant chemical will disinfect in this particular step. Okay, the water is disinfected to kill the pathogen which pass through the filters and to provide the residual dose of disinfectant to kill inactive, potentially harmful microorganisms. So it will clearly tell about what is the concentration of the amount of disinfectant required to kill the microorganism also. So the possible pathogen we have already discussed. There are viruses, especially bacteriophages will be there. Bacteria, which include the bacteria that causes typhoid, that is Salmonella. The bacteria that causes cholera, that is Vibrio. The bacteria that causes the food infection, that is Campylobacter. And the bacteria that causes dysentery, okay, that is Shigella. And there are protozoa, okay. Then like giardiasis, we have already discussed Giardia lamblia and cryptosporidia, okay. All those things we have already discussed, we have already seen. This can be removed by using disinfection. The main disinfection is addition of chlorine or chlorine derivative, that is known as a chlorination. You know that chlorine, bromine, iodine, etc. are halogen. The halogens are toxic to the microorganism. They remove the microorganism. The chlorination, there are two types of chlorine can be. Chlorine dioxide can be used, okay, that is very toxic for microorganism. That is a disinfection process. Next one, chloramination can be used. Chloramine is another chlorine derivative that transmitted. That is toxic to the microorganism. So using chlorination, most of the microorganism will be removed. Then there are, if you use bromine, that is known as bromination. If you use iodine, that is known as iodination, or if you use fluorine, that is known as fluorination, okay. In addition to this one, you can use ozone also, O3, okay. Ozone also can be used to kill. Then the water we can treat by spreading ultraviolet rays. You can see some of the water purifier UV lights are there, okay. This UV light that affect the DNA of the microorganism, and that will be kill the bacteria, okay. Straight away the UV light will go and penetrate the DNA, the genetic material, so that it will be inactivated, okay. So then the microorganism cannot survive. So these are the major steps of disinfection. So whatever we have discussed, this is the final steps. This is the raw water from any of the sources. We are adding certain. First you need to, as we have discussed, we need to add the pre-treatment need to be done, and the chlorination need to be done. Then we need to add what? We need to reduce the pH. Then we have to add the coagulants like alums, okay. Then coagulation will be takes place, okay. Then it will be, the water will be spread to the next chamber. Then there will be suspended particles, tiny flocculation process, okay. Then the water will be go to the sedimentation tank. There it will be settled, and the sediments will be collected and removed, okay. And it will be properly filtered, okay. Then it will go to the filtration, okay. There you can see the waste material. There are a lot of sand particle, okay, and it will be filtered. Finally, lot of steps will be there. It will be disinfected. So many disinfection, chlorination, bromination, or halogenation. Then finally the treated wastewater that will be distributed to the for various purpose. So this is all about this water purification steps, dear students. So I hope you understood the water purification steps, okay. And this is the once again we can glance through the main important topics studied in this particular class, okay. The chapter was the topic was begins with a brief introduction of why do you want to purify water, what is the necessity and need of water purification, and what are the steps, that is the overview, what are the major steps of water purification, what are the sources of water, what are the water purification steps and their goal, okay. What is the pre-treatment, pumping and containment, the screening, storage, and pre-chlorination. Once the pre-treatment is done, the water need to be subject to the pH adjustment. The pH need to be adjusted, then go to the coagulation, followed by flocculation. We'll add certain coagulant, then the adding certain flocculant, okay, then flocks will be produced. Then sedimentation process, finally the filtration, okay, and finally the disinfection, either chlorination or bromination or iodination or ozone disinfection or ultraviolet disinfection. So these are the all the steps that is required for the drinking water purification. These are the main important steps for not only drinking water, water purification steps, okay. So these are the main important references. You can use any microbiology textbook or biology textbook for finding out the information about the steps. Okay, so this is a beautiful, this whatever I have been telling, this so many, it's a big process. You can see a photograph of a waste water treatment, especially drinking water treatment facility. So many tanks are there actually. Okay, so big tank you can see. There are one step, so there is sedimentation tank or flocculation tank, settling tank. Okay, so many steps you can see actually. Okay, so water collected from a particular basin, okay, a tank that is kept for a very long time. So you can have so many, it's a very big process. It requires acres of land. So thank you dear students for watching this particular class. If you are having any clarification, you can ask me. Okay, thank you very much.